And hello, everyone. Thank you for joining. My name is Kevin Oloto, and I'm going to give you a presentation about building an industrial IoT solution based on open source. So, what are we going to do today? First of all, I'm going to give an introduction about Eclipse Vorto. Then we have an introduction of Apache PLC4X. And then third, we are going to talk about how to bring the two together with Eclipse Ditto to build an industrial IoT solution. I was planning to give this talk with Julian together, but he was not available to join today, but he has sent his presentation as a video, so we will be able to have the full presentation. My name is Kevin Oloto. I'm working with Bosch.io, and I'm the project lead of Eclipse Vorto. And we are talking about Vorto first. So what is Vorto? Vorto is an open source project for semantic modeling of digital twins and their capabilities. The project consists of Vortolang, which is a domain-specific language to describe digital twins. This is the core of the project. This is used to create the models. And then the project consists of the repository, which is used to create, manage, and distribute models. We are using vorto.eclipse.org as a location where we host a centralized repository for everyone to use. But if you want to host your own repository, you can also do that by using the tools that we provide. Then we have the Vorto plugins. Those are used to transform models into something else. So this could be either source code, snippets, or request templates, or other representations in other semantic modeling forms. Then we have the final component, which is the telemetry payload mapping. This can be used to map the data that is sent by the device using the mapping specification that is based on a Vorto model, and transform the payload into a normalized canonical format or a specific format like Eclipse Ditto. Let's have a deeper look into Vortolang and see how it actually works. So Vortolang has several components. The top level component is the information model that describes the digital twin and its capabilities. One information model always have one or multiple function blocks. So the function blocks describe the actual capabilities that are implemented by the digital twin. The function block has 4 different types of properties. The first type of property is the status. Everything that is a status property is per definition read-only. So for instance, this could be a sensor value. Then we have configuration properties. Those are properties that can be read and written. Mostly those are properties used for configuration. That's why the name is configuration, but also could be something else that just has read-write access. Then we have events. Events can be defined to describe the data that is being emitted by the device under some certain conditions. So whenever a device throws an event, this can be modeled in Vortolang in the event block. And fourth, we have the operation. This is a function that can be invoked on the device. So we can describe functions that have several parameters and have a certain return value on the device. The next type in the Vorto language is the data type. This can be used to describe complex data types or enumerations that can then be assigned to function block properties. And the final component of the Vortolang is the mapping. The mapping can be used to describe platform and implementation specific information. This can be useful when you want to have something that is very specific for your own platform, but you want to keep the models, so the function blocks that you're writing, as generic as possible, so they are reusable. So then you can use mappings to add the platform specific information and combine them through the APIs that the Vorto repository offers, while keeping the models generic at the same time. Let's have a deeper look into the repository. So as I already mentioned, we have one official repository at vorto.eclipse.org, but it's also possible to self-host your repository. The repository is a Spring Boot application that you can also run on your own. The repository offers a UI where you can view and edit the models, and it offers API to interact with the models, for instance, create models, delete models. The easiest way to work with models is through the web editor. It provides some content assist and some validations, so you're not on your own when you create your models. And you can use the repository release and review process to have a process in place when you want to graduate your models from a draft status to a released or a published status. There are two different levels of visibility, public and private. Public models can be accessed without any authentication by anyone, while private models can only be accessed by collaborators in the namespace that you're working in. The repository also offers to import and export models. This can be useful when you have multiple repositories and you want to transport models from one instance to the other. And there are several integrations with plugins. Plugins, we will talk about that next, so I will not say anything more about that yet. And then there's the Java client that can interact with the repository that we also provide. The Vorto plugins can transform Vorto models into other representations. This could be source code or request templates or something else. We have a set of official plugins that are within the main Vorto repository and that are also integrated with the repository, so you can directly use it from the UI. And we have a couple of experimental plugins that we do not link directly in the repository, but they are available and they can be used. Among the official plugins, there's one plugin for the Bosch IoT suite where you can generate certain useful requests or code templates that you can then use with your devices. There's the Eclipse Vorto plugin that you can use to generate code based on the Vorto model that you can then use for sending telemetry data to Hono. And then there's the Eclipse Ditto plugin, which can do two things. It can generate a Ditto thing JSON representation, so a digital twin representation, or a JSON schema representation, which can be used to validate payload of the device. We will use this Eclipse Ditto generator also later in our example. Then we have JSON schema and OpenAPI official plugins, and we are currently developing a Web of Things plugin that can convert a Vorto model into a Web of Things thing description. Among the experimental plugins, there's, for instance, Azure IoT, where you can convert your Vorto model into the DTDL. And we also have a couple of other plugins in the repository, in the GitHub repository that you can use if you want to. The last component of the Vorto project is the Vorto payload mapping engine. This is a standalone component. It's a separate Spring Boot application, and you can use it to load the mapping specifications from a Vorto repository and then receive telemetry data and map the data based on those mapping specifications. Currently, we support JSON and CVS as input formats, and we have 3 supported output formats. This is a Vorto canonical JSON, a Ditto JSON, and an AWS Kinesis format. The protocols to interact with the payload mapping engine is AMQP at the moment. The entire component has a plugin architecture, so whenever there are new formats or new protocols needed, they can be implemented very easily. All right, let's have a look into the repository. So I will show 2 models here that we're also going to use later in the demo. So we have here a function block for a virtual machine. This virtual machine is a model of a PLC, so of a programming logic controller. It has a couple of properties here that you can see. They are configuration properties, so they have read and write access. And you can see up here that there are 2 mappings associated with this model. So let's have a look at the mapping. This will become relevant in the demo as well. You can see here as an example how a mapping works. You first define the target platform that you're going to use. So this is our demo target platform that we are using in the example. And then you can use this syntax to map a specific property. And you can add your platform-specific data here. So for instance, we use this to add the URL of the machine and the address of the specific value that we're going to read from it, and we have a reading rate here. All right, so now I'm going to start the video featuring Julian, and he will continue with the rest of this presentation.
So, hi everybody. My name is Julian from Stuttgart, so the south of Germany. And sadly, I'm not able to be here for you live, so I pre-recorded my part of the talk. I hope that you will still have a good experience. And if there are some questions, Kevin will surely happily answer them. So, to start into our discussion, this is me. I'm Julian, as already said. I'm a mathematician by heart. And I will talk a bit about a project today which is not from Eclipse, Apache PLC4X, which is an Apache project, where I'm one member of the PMC. And what Kevin and I did is to integrate several projects from Eclipse and from Apache to sketch you a complete industrial IoT solution and how to set it up and how it would work. So to start off with a short introduction to PLC4X, we see lots of these slides these days where we talk about a lot about Industry 4.0. So when we talk about industrial IoT, we usually mean machinery, plants that should be connected on consumer electronics. And you see there are many things that you could do, or people say you should do, and how to go upwards the value chain, basically. But there is always this crucial step too, connectivity. So you have to connect these things. And it's no issue for consumer electronics, as we simply build in the right interfaces we need to push out messages. But for machines, for new machines, that may be possible. But for existing machines, connectivity is an issue. And there are multiple reasons why this is the case. One is that usually there are proprietary protocols used. There may be drivers, commercial drivers that you can buy, but you have to buy a different set of different driver for each kind of machinery you have, or each manufacturer. And some may work on Linux, some may not work on Linux, some may work on Windows, others not. Then those protocols are incompatible. Sorry. There are some standards like Modbus, Ethernet IP, or also OPC, but they are not the native protocols. They usually are add-on on those controllers, and they therefore some features and the native performance you usually only get when using the native protocol. And this is how the PLC4X project came to life, with two major goals, so to say. One is to have a central place where we provide and develop drivers for those PLCs, but open source and a business-friendly open source license. In this case, it's the Apache license, but it's fully compatible with the Eclipse license. And the other thing is a common API. And this is also an important point if you think at the database world. I don't know if you could imagine a database world without JDBC or ODBC. I could not, because you would need to think about which database will be used later on at programming time. In some cases you still have, because SQL is not as standardized as one would like, but only in very, very minor parts. Usually you can just swap out via configuration to use an SQLite for testing or some kind of embedded database and go to another database in production. And this is a nice thing. And the same thing we want to achieve for communication with machinery. So this is the picture. We have a PLC4X API, which is heavily inspired by JDBC. We have a set of drivers which were hooked in a mechanism similar to JDBC, not exactly the same. And then an application can either work directly against the API, or we provide different integrations already out of the box in the project. And and it's just a configuration that defines which kind of protocol or which kind of PLC you will address. I will shortly talk also about OPC UA now, because this is usually a point where people ask, okay, but why don't you just use OPC UA? At least people that are familiar with the matter, because OPC UA is one of the newer protocols, I would say, and the name also stands for unification. The U in the name stands for unification. So it basically wants to solve the problem we have at the shop floor. The same problem PLC4X wants to solve, but they do it in a different way. Thus, this chapter is named same but different. It's most easily explained using a simple example. Let me jump over here. So we have this application here, and we want to communicate with some of our machines we have at our shop floor. So first try using OPC UA. We just use an OPC UA client and we connect to different OPC UA servers. And now we see that we are probably lucky and we have a Siemens device which is reasonably new, so which has an OPC server on board. That's something the PLC needs to have. There are other controllers which may not have an OPC UA server on board, or probably which do not have all information in the OPC node tree, because that's something you have to, it's a parallel protocol that you also have to re-implement, basically. The machine manufacturer has to re-implement. So we will at least be able to connect to a subset of the machines. And the protocol used is here's OPC UA. So they also define a wire protocol. So what are the pros and cons of this approach, or the drawbacks? The OPC UA service that has to run the controller places heavy load on them, and just now they are getting stable enough that they work in all cases with all firmware versions and stuff. So we also have clients where we cannot use OPC UA because the firmware version they have, the OPC UA client, isn't stable there. These are things happening in the field. Another thing, as I already said, it's another definition that you have to keep in parallel to your original programming. So everybody, the machine builders, the programmers, but also the people at the shop floor, have to get used to the protocol, have to learn how to use it, which information to store them, all those things. The nice thing is that propagation increases rapidly for new machines, but most of the old machines, everything you already have in your plant, all those thousands of machines out there, billions of machines out there, do not have OPC UA connectivity. So although the market is growing rapidly, it will take many years till most of the machines support OPC UA. Another nice thing about the protocol is that it's very powerful. It supports things like encryption on the wire, and subscription-based protocols, signing of messages. But the drawback is it adds overhead, which can sometimes be an issue. If frequency or sampling times get really high, that's an issue because it takes away CPU power from the PLC. So how would the same example look like if you use PLC4X? In our example, for the application, it's not that different. Again, I'll jump over here. So except for the PLC4X client, you have the PLC4X API here. And in fact, there's even a PLC4X driver which would put the PLC, the OPC UA driver basically here. But the nice thing is that we support several drivers. In this example, of course, I've only added machinery with drivers we support. And then you can communicate with the machinery in the same way. But another nice thing is that you communicate via the native protocols, which the PLCs are best at, basically, at answering or working with. So this is a nice advantage of using the PLC4X protocol, basically. I mean, there are good reasons, I would say, for both solutions to exist. Another nice thing about OPC UA is that OPC UA is not only a transport format, but also semantics. So they define what kind of value this is, what measurement unit this is, probably even what quality this is, when it was exactly physically taken, have a nice name for the machine. With most of those wire protocols that you use basically direct via PLC4X, it's just bytes that you get over the wire. Some do not even store a type for the information. That's basically like grabbing into a byte array and fetching something out of it. And you have to know what was stored there and with what encoding it was stored there to deserialize it reasonably, which is tough work on the configuration side of things. So this is something that OPC solves way, way easier. And therefore there's also a perfect reason to incorporate OPC UA in such a setup here, because when you have it accessible, it's usually nicer. But going away from PLC4X, now going over to the Industrial IoT Solution. The scratch implementation we have done basically has this idea that you have one place where you define your machine, what capability does it have, what measurement drivers does it have, which is done in Vorto. Then you have Dito, where all the information should be stored, and then you have some kind of gateway near the machine where PLC4X is running, which on one side fetches data from Vorto to know what exactly to read and how to name things, and then pushing it over to Dito. We do not have a special introduction or separate introduction to Eclipse Dito because it's, I would say, rather known. I mean, this picture tells you a lot about Eclipse Dito and its use case. So basically, it's some kind of common interface, probably, where data generators can push in their data change updates, and then clients that may either be front application services, whatever, can either fetch them actively when they need them or get notified via events or something. And Dito takes care of everything, and of policies that not every user can see every value, or not every user can write every value, and all this management, and comes with this nice idea of many parties working together on common data sets, basically, or on common databases. So this is how a simple application would look like, and you could have a PLC4X running there, fetching data, pushing it to Dito, and the front end could use it. If you go to a more production-ready scenario, then you would have different networks, of course, and Dito would be in some ways into both networks, but usually you would use some kind of messaging protocol, MQTT, MQP, or simply go to Eclipse Vorto, which is a very nice integration layer to basically solve the transport. And there's also the Eclipse IoT Packages project, where you get both of them already bundled as ready-to-use Helm charts for your Kubernetes cluster. And then you also have the right side here in the picture, where you have to expose the Dito API to the public, basically, or at least to your front end, which may be an UI, an app, and a service, whatever. But then you have really production-grade setup, I would say. Another thing that I forgot to mention previously when talking about OPC UA and PLC4X is a third approach that is currently emerging, an alternative standard, I would say, to OPC UA, which is Eclipse Sparkplug, which is developed in an Eclipse working group also, and which say, okay, we already have MQTT as a pretty good transport protocol and transport layer here. So all we need is to have some kind of schema definition on top of it, or semantics, and this is exactly what Sparkplug solves. So this is something which may be also interesting for PLC4X, that Sparkplug integration there, but which is especially interesting to mention here at an EclipseCon, of course. So this is basically standard, I would say, Dito setup, and the setup we prepared for this example is a bit more complex, as shown here, because we also include Vorto here. And what does Vorto do in this context? I already said initially, it takes care of the schema, but not only of the schema, but also with its mapping of the implementation details. What do I mean by that? In this example, we have 3 machines and PLCs that could be similar. For one example, for one moment, we assume that they are similar. They have a temperature we want to know, they have a motor speed we want to know, and probably other others. But all of these machines were programmed slightly differently. This seems odd, but this is the truth. So we can use a common model. This is this kind of machine. It always has a temperature and a motor speed. But for each machine, we have to know, okay, where do I get the temperature reading exactly from? How do I get this? And where do I get the motor speed from? How do I exactly get it? And these two tasks are taken over by Vorto. So the gateway, when it starts up, first queries Vorto to get the schema, to know, okay, what kind of messages do I have, and also the schema can be used to already define or to create a thing in Dito. But also it gets the information, okay, where do I get my readings from, with which frequency, and all this information. So this is all done via Vorto in this example here. And then data is simply pushed to Dito. And then a consumer can address it. But the really nice thing here is that the consumer only needs to look up basically a Vorto repository to see what he can expect later on from Dito. Everything is defined in the Vorto repository to see how the Dito queries should have to look like later on. This brings me to the nicest part of this session, to a demo. So what I prepared for you there is a repository which is open. I will share the URL again after the talk. And here I have an implementation of this gateway, which we can shortly have a look at, which does basically what I said to you. Initially, it goes to Vorto, to the Vorto repository. You see here the public Vorto repository, and it fetches the model for this virtual machine, how we called it. And this virtual machine has a temperature and motor speed and some other properties. You can look it up in the repository at version 1.0. And it takes the thing JSON, and the thing JSON is exactly the payload of the message we have to send to Dito to create this thing. So this is something Vorto takes care of it. Nice. The next thing is the mapping. As I said, in theory, and oftentimes also in practice, all those machines could have the same definition, but slightly different implementations. So for each machine, we probably need a mapping. Where exactly is the temperature stored on the machine? How do I get it? So you see here, Vorto maps for us the model virtual machine with an implementation description, which we call demo SPS pragmatic, which is the SPS is PLC, which is a PLC I have here in my basement. So if I would go to a client which has the same machine, in theory, we would just swap this name here. The model stays the same. So it's kind of an interface in that sense. Okay, what's happening then? Lots of technical steps. We instantiate a Dito client. We generate a random UID for a thing. That's just that we create a new thing each time. And then we create this thing. And we use this Dito JSON we got from Vorto basically to create the thing. And when creation is successful, so status of 200 something, it could be 201 if the thing is newly created, it could be 204 if the thing already exists, I think. So we just check if it's below 300. And then I basically start to fetch values from the PLC, to scrape the values. This is done here. We fetch them from the mapping part that we got from Vorto. We figure out the right parts to know, and then we schedule the fixed rate or PLC connection. We do here to the URL we got from Vorto, the field name we got from Vorto, and the address we got from Vorto. The field name is just placeholder internally. And then we fetch it, and also the rate we get here something we got from Vorto. So if we would change the mapping in Vorto, we can fully define how often we fetch the value. And then the last thing we do here is when we successfully got the value, we send it to Dito. And that's it. Initially, I said something about when working with PLCs, you do not always know how to interpret the byte array you get over the wire. And this is an interesting thing where again Vorto comes into play. This is this method here, where we know from Vorto what this should be. It should be a double or a boolean or an integer. And this helps us to interpret the value in the right way and to push it in the right way to D2. Otherwise, PLC4X would just guess what the type should be, which does not always do what you want it to do. Yeah. So with an eye on the clock, I will go over to a short demo. So let me just start the program for a second. I hope it's yeah, we make it a bit bigger. So okay, first thing we see that a thing ID is created, and then the status was 201, so the thing was created. Okay, nice. And here we print out some configuration properties. People that already worked with a PLC will recognize those values. This is the address format you use on a Siemens PLC. And then you here see drivers are registered, connections are started up. You will see in the log also some connection failures, which is because we do too many connections. In a production grade application, you would use some kind of connection pool, which you also brought in the PLC4X project. In this case, we simply open up a new connection every time, so every 5 seconds. And sometimes it fails. This is just due to the nature of our setup here. But now we can go over to the Eclipse D2 instance I just used. This is an old example, so I paste in the newly generated ID, and I fetch the thing. Okay, and it's not correct. It's not. So probably, I will log out and log in again. Sorry. And now let's see if I got the right thing ID, because I should have the right admin rights. Okay, so I paste the thing again and execute. Okay, now it works. Don't know what went wrong here. Okay, so now you see I got the current values. And every 5 seconds, if I reissue the query, it should change slightly. You see the position, for example, changed. There's a simulated machine which is in theory running, and if I execute often enough, then I should, yeah, now you see the process state went from 4 to 5. So I think time is nearly over now, so this basically closes the short demonstration we prepared. Here is the repository we created, Kevin and I created. We were also preparing a blog post where we describe it in detail. But the thing we just want to transport you is that we have a full solution in the sense that we can define things, define semantics, have a gateway, but also can store the values in a good, nice and secure way. This sums up my part. If you have any questions, sadly I cannot answer them directly, just ask them Kevin. Or if there are further questions, just ping Kevin or ping me, and we are really happy to help you. Thank you for your time and enjoy.